Hello friends, in today's question, a solid cylinder rolls without slipping on an inclined plane, inclined at angle theta. Find the linear acceleration of the cylinder. The mass of the cylinder is m. So we have given the cylinder and at inclined plane. Let us suppose this is inclined plane at an angle of theta. And we have a cylinder and it says that it rolls without slipping. Okay, so there will be, let us suppose it is rolling in this direction with the angular acceleration of alpha, and the linear acceleration of the center of mass is given as A. So the torque which will be forcing it to, you can say, roll, will be produced by the force of friction, which will be acting in the upward direction. So in this case we are going to have two forces, rather we can say mg acting downward, and this mg can be divided into two components. One will be along the inclined plane and another one will be normal to the inclined plane. So we are going to have mg cos of theta, and this will be mg sin of theta, and there will be a normal acting between the contact surfaces of the cylinder as well as the inclined plane. So we can write the equation for the motion for the linear acceleration. You can say that for the linear acceleration, A the equation for the motion, and it can be written as mg sine of theta minus force of friction, and that will be m multiplied by A. Let this be equation number 1. Now it is said that there will be a pure rolling motion without any slipping. So therefore we can say for rotational motion about the center of mass, the torque caused by the frictional force will be producing the angular acceleration. The torque caused by the frictional force, which is given as Fr, provides the angular acceleration. Which is given as alpha. Therefore, we can write the equation as Fr multiplied by R will be equal to I into alpha, where I is moment of inertia of the cylinder and R is the radius of cylinder. Now it is also given that it is pure rolling motion, there is no slipping. We can say cylinder rolls without slipping. Therefore, we can write the relationship between the linear acceleration as well as angular acceleration. So therefore, we can say A will be equal to alpha multiplied by r. So here we can say the alpha is equal to angular acceleration divided by radius r. And the moment of inertia of the cylinder, that is I. Moment of inertia for solid cylinder, which is given as I, is equal to half m r square. So substituting these two values, let us suppose we call this as equation number 2. So using equation 2, we get frictional force Fr multiplied by radius r is equal to half m r square, and alpha is given as A upon r. So here r goes away and we get that Fr will be equal to 1 by 2 mass into acceleration. So this is the value of the force of the friction. Now we are going to use this value of force of friction in equation number 1. So we can say from equation 1, we get mg sine theta minus substituting value of Fr, which is equal to half mass into acceleration is equal to mass into acceleration. Now we can cancel mass throughout. So this we get g sine of theta is equal to A plus 1 by 2 A, and this comes as 3 by 2 times A. Now it is simple manipulation. From here we can say acceleration is equal to 2 by 3 g sine theta. So this is the linear acceleration of the solid cylinder. This is the linear acceleration of the solid cylinder. So this completes the question. Thank you.